video-based laboratory report includes the analysis of the motion of an object in two-dimensional motion. The researchers researched a video presentation about projectile motion, and the researchers found one that is like the motion of a ball rolling off a cliff. The video that is picked shows that there is an initial velocity for an object to be able to move. Also, there is a final velocity that is reached when the ball reaches the ground. After analyzing the video that is purely based on it, the researchers analyzed the video through mathematical means. Aristotle believed that projectile motion is the rate at which an object falls was directly related to the mass of the object. But then, Galileo Galilei questioned Aristotle's beliefs and made an accurate description of projectile motion. Today, projectile motion is described as a curved path, or parabola, an object follows when thrown or propelled near the surface of the earth. Trajectory is what the curved path along which the projectile motion travels is called.
Preview.
In this video-based laboratory report, there are objectives that the researchers set for themselves. These objectives include to be able to analyze in detail the motion of the rolling ball in two-dimensional motion, and to check the existence of possible systematic errors by comparing the theoretical computation and the actual result. In this laboratory report, the group of researchers analyzed motion in two-dimensional motion by watching the video and analyzed the motion by mathematical means. A video is to be the output of this research. Theoretically, if a projectile is rolled at a specific angle and a fixed speed, it should have an arc-shaped trajectory. This is if you disregard the air resistance, mass of the projectile, and the shape of the projectile. Using its speed and the height of the cliff from where it was rolled, the range of the ball can be computed by using the equation r is equal to v0 squared times sine 2 theta over g. We could analyze this video by using tracker, or we could solve it using kinematic equations, which would help us find the different values such as initial velocity, range, and many more. These particular equations need some starting values to compute for the other values. That is why rolling a ball would be easier due to it having a fixed initial velocity compared to simply throwing a ball. Throwing a ball would lead to inconclusive results due to the slight differences caused by many factors like unnecessary movement, less initial velocity, wrong angle, and many more. For this problem, we will be solving for the range. To find for the range, we first need to identify the given value stated in the problem. After identifying all the given values stated in the problem, we need to set up equations that will help us find the range.
Preview.
After setting up all the equations needed to find the range, we then substitute all the given values to these equations and find the total time of flight. After finding the total time of flight, we can then now find the range.
Preview. Preview.
Observing the factors that affect projectile motion and using kinematic equations to find the other values, we were able to reach the conclusion that there are many factors that concern projectile motion. These factors include initial velocity, height at which it was rolled, acceleration due to gravity, and the displacement of the projectile. These are the major factors that affect the projectile motion after disregarding the wind resistance, shape, and weight of the projectile. We also reached the conclusion that the rest of the values could be computed using kinematic equations. This new knowledge would help us solve future experiments and problems.